Hello friends, welcome back to the next video of DBMS practical lecture series. In this video we are going to discuss about very important topic of DBMS, that is joins. And for join you must know about the Cartesian product first, because Cartesian product plus join condition will result in join operation. And for any further operations or for real life applications as well, we need to deal with more than one tables, and every time we need to write the query with join operations. So you must understand the join concept first, then other operations. So let's start. First of all, the definition of the Cartesian product, because Cartesian product we can say that is prerequisite for the join operation. We will be having two tables. For example, we are having R as the first table and S as the second table. Then this is the sign for the cross product, means the Cartesian product, and the result will be the concatenated tuple like this, where X is the tuple from the relation R and Y is the tuple from the relation S. Okay, and by this definition you may guess that we will be getting the tuples from both the tables in concatenated manner. Okay, so this can easily be understood with a pictorial representation like this. Suppose we have R as the first table and S as the second table. In this case we have two rows in R and also we are having two rows in the second table S. So for Cartesian product we will be having the combination of rows of first table with every other row of the second table. Okay, and here suppose x1 will be concatenated with y1. Similarly x2 will be concatenated with the y1, means both rows of the first tables are concatenated with the with row 1 of the second table, and this will be first operation. And after that we will be having the combination of both rows of R table with the second row of second table. Okay, so as a result we will be having 2 into 2, means 4 rows in the result of the Cartesian product for these two tables. Okay, if we have suppose 3 rows in first table, 3 rows in first table and 6 rows in second table, then we will be having 18 rows as a Cartesian product result. Okay, so this we will be having with example. So now you must know the conditions, like R and S table need not be aggregate operation compatible, means unlike aggregate operation union all, minus, intersection, where we were having the operations with only the compatible tables or compatible selected columns, means the column must be same in name. Okay, for aggregate operation they must have same name, they must have same order, they must have same domain. By domain we mean the data type, means everything should be compatible, only then you can perform union, minus or other aggregate operations. Second thing is, this operation is expensive. Suppose we have thousands of rows in one table and thousands of rows in second table, so it is going to take a long time to calculate the Cartesian product. Now let's take an example. Suppose we have R as the first tuple with these two rows and S as the second tuple with these two rows, and we are having no column as a common column within these two tables. But in real applications, this is just for the representation of Cartesian product to understand it clearly, but for the real application we will be having relations within the columns of two tables. By relation we mean the referential integrity constraint or primary foreign key relationship that we have already covered in practical 3, because without that relation we cannot build a database for an application, right? So here for the Cartesian product we are taking simple table, then we will be moving to the primary and foreign key relationship with the student table example. So here we are having 4 columns in the resultant table for the Cartesian product. Now as we have discussed, both rows of R1 R table will be combined with the first row of the S table. So here after this Cartesian product, we will be getting these two rows as the first two rows of the Cartesian result, and after that we need to form the concatenation of all the rows of table R with the second row of table S. Then this will be your final result of the Cartesian product after from these two tables. Okay. Now let's have an introduction of join, then we will move to the practical example. So here the joins, we can say that when we join, when we perform some join selection condition after the Cartesian product, so Cartesian product followed by the join condition will form the join operation. Means we are not selecting all the columns, all the rows, all the columns from the input tables, but we are performing some selection over the columns or over the rows. That's called the join condition. Okay, that will be clear when we start with the example. So here the difference between Cartesian product and the join is that the resulting relation from the join will consist of only those tuples that satisfy the join condition. Means the conditions of projection or selection will be applied to the Cartesian product, and only the selected columns or rows will give the join result. Okay, so here this is the symbol for the join operation. If you are writing the join operation in papers or representing in document, then you will be writing this symbol for the join operation. And A table, here the first table is your A, and that is joined with the table B depending on some join condition. Okay, so let's take the example that we will be implementing today. Here is our first table, that is student table with 3 rows, and this is our second table with 2 rows for the books issued from the library. So every student who is an authentic student will get the books issued from the library. No other student can have the right to get the book issued from the library. So only the valid roll number should be there. So here we will be having the primary key and foreign key relationship. This roll number is the primary key here, and this roll number is the foreign key in the library table. Okay, and we have already covered the primary key and foreign key relationship. If you have any doubt, then you can watch the practical number 3. So here we will be having this relation within these 2 tables, and if we calculate the Cartesian product of these 2 tables, so Cartesian product will give us this result. Means as we have 3 rows in table 1 and 2 rows in table library, so we will be having 3 into 5. Okay, 6 rows as the resultant Cartesian product. So here the 3 rows are combined with the first row of the table 2, or that is our library table. Similarly, the combination will be formed with the second row of the library table. So this is our Cartesian product result. Now if you analyze this result, this is Cartesian product result, but if you think logically or analyze this result is of no use. This is giving you no information, just the number of combinations. Okay, but if we need to extract some useful information or some useful records from this result, then we need to apply some condition with the Cartesian product. Okay, for example, if I want to know the names of the student who have got the book issued from the library, okay, then I need to add certain condition after the Cartesian product to get that name. Okay, so here, so as you can see, the student and the name, roll number column is repeated 2 times here. That was not required. Okay, because we need the names. Secondly, we need only the column satisfying our condition, and our condition is the book, the student must have got some book issued from the library. Okay, so I think you can analyze the records of our interest. Means we need the roll number that is also present in the library table. So we have the matching record as this. Means only the roll number 22 has got the book issued from the library, and the book is DBMS. Now I want to extract the names. So the name is the Diya. Name is Diya, who has got the book issued from the library. And the second record of our interest is where the roll number from the first table is same as the roll number from the second table, and the row is the last row where we have roll number 33. From this result we can see that the matching roll number is 33 in the last row, and the book is Python, and the name of the student is Mia. So these are two records of our interest. That means that these two records are giving some useful information to us. So to extract these two records from the Cartesian product, we need to apply some join condition. Okay, I hope you are getting the point. So now if we apply the condition we need to apply and the query we need to perform for Cartesian product, we will be having in practical session. Now let's discuss the results first, because if you understand the result, means if you are able to understand the logic why we need to apply that query, then you can easily form the queries by yourself. So let's start here. After applying certain condition, means if we apply the condition for rows, then we can extract these two rows from the Cartesian product. Now what is that condition, we will see in practical. Now if I still analyze this result, this is having roll number column 2 times, that is the roll number is ambiguous column in this result. Okay, so it is giving you the same information. So if you want, you can easily cut one roll number column from the result after applying one more condition to this result. Okay, and as a result you will get this table. Means here you can have only the roll number, name, branch and book. Means roll number is displayed only one time, and if you only want to see the name, we don't require the branch information of the student, then you can apply that condition too with this result, and you will get this as the resultant table, where you can have the information of only the roll number, name of the student and the book issued to the student. Okay, so let's see how we can move from this result to this result. Okay, and from this result to this result, means how to eliminate the common column. Next we will see how to extract the columns of our interest only, means we are requiring only roll number, name and book. Then how can we write the query for that? So let's start with the practical demonstration. Here we have already created the table named student. Okay, and if we describe the structure of the student, we can see that we have not applied or added the primary key to the table. Okay, so let's revise the concept, and simply I am going to add the primary key to the student table for the roll number field. Then we will construct another table, that is our library table, and then we will see how to write the queries for the Cartesian product and how we can apply the join conditions for our desired result over the Cartesian product. So let's start. So to add the primary key, we simply need to alter the table student add primary key, as we have already covered this thing in previous video. You can also give the constraint name, as primary key, foreign keys are constrained. You can always give the names, means add constraint name, then primary key, but I am not giving any name just to save time. So you must give the names as we have covered already. So alter table student add primary key. So table is altered and the primary key is added. So let's check by describing the structure. So this is the result, means the table is column is declared as not null and must be unique, must contain the unique values. Now let's create another table, that is our library, with two fields, roll number and next column is book. Now we will be adding foreign key to it. Because foreign key referential key constraint, your applications database is useless. Okay, so I want to create this roll number field as the foreign key, and it will refer to the roll number of the student table. Okay, as we have already discussed the significance of this. And I am keeping the column names same intentionally because we need to check how the result will be changed when we are keeping the roll same name field in the two tables. Okay, so I'm keeping this name same names, but you may have different names for the your secondary table, means library table, but you can also have the same name. For that you need to add certain condition that we will be covering in this video. So here roll number is added as a foreign key, and it will be referring. So for that you need to write references. It will be referring the student table. Okay, so here you need not to provide the primary key column name here. This is totally option. You can also write like this, means the roll number of the library table is referring the roll number of the student table. Or even if you omit this thing, it is understood that a column declared as the foreign key will be referring to the primary key of the referred table. So it is by default referring to the primary key of the student table, and primary key is our roll number. Okay, so let's run this query, and table is created without any row. So let's quickly insert the rows to our new table. We will be entering the same values as we have discussed in the slide. We must use single quotes with the string columns, string entries. So here the roll number, first roll number was 22 and entry was DBMS. If you try to give any roll number that is not present in the student table or not added in the student table, then you are going to get the error, means that row will not be inserted into the library table because of referential integrity constraint. Okay, you must know this thing. So let's repeat this command. This time I am going to provide the roll number as 33 and book as Python. So two rows are inserted. Select to display the row. Let's display the tables. Select star from library and select star from student. So these are our target tables. Okay, so let's commit the changes, otherwise we'll lost the rows or the primary key added to the tables. So I'm going to commit the changes. All the changes are committed, means saved. Now after this I am going to run the command for the Cartesian product. Okay, so first we must open another command prompt so that we can easily compare our result with the target tables, input tables our. This command prompt is just to display the results. Done. So tables are select star from student. So this is our first table. And this is our second table. So this is our library and this is our student table. So now I am going to write the query for the Cartesian product. So for that you simply need to write like select star from student and the second table name as library. Okay, and here you can easily compare the result. The first 3 rows are the concatenation of all the rows of table 1. These rows combined with the first row of the second table. And the next 3 rows are the concatenation of the first table with the second row of the second table. Okay, so this is our concatenation result. I hope you can easily analyze by seeing the input and the result. Okay, that's why I am keeping 2 windows just for the analysis and to easily understand the results. So now I am going to revise this result by applying certain conditions. So I want to apply join condition, that I want to extract the records where the roll number in the first table is same as the roll number in the second table. Okay, so I am going to repeat the command, but this time with the condition like where student dot roll number is equal to library dot roll number. Okay, so here is our second desired result, means we got the records that are having the same roll numbers 22, 22, 33, 33. And please note here, if I am not writing student dot roll number or library dot roll number, then you will be getting error because we are having same column names. Okay, but if you were having the different column names in 2 tables, like if I am having serial number in the library table and roll number in the student table, then you can simply write where roll number equals to serial number. Okay, so you can simply write the column names if the column names are distinct, but as I am having the same common column name, then I must differentiate them with the table name. So here I am differentiating it with the table name dot roll number, library dot roll number. Okay, if you are having different names, then you can simply write roll number equals to serial number. Now our next desired result is I want only the columns, distinct columns. Here I am having the ambiguous column as roll number. So if I want to extract only the required column, then how can I write the query? I need to write the columns names. In that case, instead of this star, I must mention the column names, and the columns, if you are mentioning the column names, that operation is known as projections. This is the selection query. Because this query is selecting the rows, means this query is for the selection of rows. So this operation is known as selection. If you are projecting some columns, means if you are extracting certain specific columns, then we call it the project operation. So for that you need to revise the query like select, I need to get the roll number. This time I am going to get the roll number of student table. So student dot roll number, comma, name, as name is the column belongs to first table only, so you can simply write the name, and branch is also the unique column name, so simply write branch. And third is our book, and book is also the unique column name. Okay, if you can see, book is also the unique column name, so you can simply write the unique column name, but for the common column name, as roll number is not the distinct name, so I must mention the table name with dot operator. Now where clause, where, what is our condition? Sorry, I lost the query, so let's write it again. Student dot roll number and distinct column name, distinct column book. I also need the branch. You can extract or write the column names in any order. Book from student and library. You can mention the query in any number of rows, means you can write the query in parts. Where now we have this is our projection, means we are projecting these columns, extracting these columns only. Now we need selection condition for extracting two records, two rows, where we can write student dot roll number is equal to library dot roll number. Done. So our query is complete. Hope I have not made any syntax mistake. No. Okay, one comma was extra, so let's remove this comma and start. Select student dot roll number, name, branch, book. Here one comma was extra. Next, from student and library, where student dot roll number is equal to library dot roll number. So now the query is complete, and here is the result. Okay, in last query I mistakenly added one extra comma with along with the last column. That was an error. Now this is our result. Now if I want to extract only roll number, name and book, then I can also make our changes to the query, means I am going to remove the selection or the projection of the branch column this time. So I need only these three columns. Okay, from table student and library, where the student dot roll number is equal to library dot roll number. Okay, so now I am going to project only three columns: roll number, name and the book name from the two tables. So here, so now the result is three columns and the projection of three columns and the selection of two rows. Okay, so this is our projection operation and this is our selection condition, right? I hope you understand this thing. And last, I am going to edit the query for the aliasing operations, means we can create the alias of the table, and we have already covered aliasing of columns and aliasing of tables in the earlier videos. So let's do it one time more. So here s dot roll number means s is the alias for the student table, and next from student and library. Now this time I need to mention the alias name, so student is renamed to S. Okay, similarly I am going to rename library table to L. Okay, here I can also write L dot name, S dot name, S dot branch, or L dot book. Okay, so you can add the column names with the table names or table alias name, but only for the common columns, as I have written S dot roll number. Okay, now what I need to write, where roll numbers are equal. So the condition is where S dot roll number, this time I am not going to use the complete table name, S dot roll number is equal to L dot roll number. So the query is complete and here is the result. Okay, so here we are getting 4 columns because I have written the branch column name also, but you can edit it to 3 columns result. Like you can remove this if you want only 3 columns. So this will be your resultant query. This will be your resultant query. Okay, so this is a small demonstration of Cartesian product and how we can extract the results from the Cartesian product as a result of join operation. So this is an example of the simple join. In next video we will be discussing more about join and different types and varieties of the joins. So till then, bye and take care.